Welcome to the first episode of Mr. Brock's Awesome World of Algebra. I'm Mr. Brock, and I have a paltry algebraic dilemma for us today. This is a uniform motion problem, or as I like to call them, the trains, planes, and automobile problems. There's three types of uniform motion problems that we're going to deal with. They are the same direction, the opposite direction, and the round trip. Let's look at this example. I'll read it to you. You should read it to yourself. Usain Bolt begins running north at 3 o'clock p.m. going 20 miles per hour. At 3:50, Mr. Brock starts running north going 25 miles per hour. How long will it take for Mr. Brock to catch Usain Bolt? Okay, this is a same direction problem. First, let's visualize what's going on here. What we have is one person starts running in a given direction. They have a head start. They're obviously going slower. The faster person takes off at a later time and begins running the same direction. What you need to realize is when the second person catches the first person, they have both gone the exact same distance. Now, another thing that we need to know to solve this problem is the formula for distance, and it is this. Distance is equal to rate times time. So when I read through the problem, I'm going to be especially careful looking for rates and times. Now, all of these problems, be they same direction, opposite direction, or round trip, you'll be asked to solve for either the rate or the time. The best thing you can do is set up a T-chart to solve this, and that's what I'm going to do right now. First of all, since this is opposite direction, or excuse me, same direction, my chart will look like this. Okay. Highlighter. I know that Usain Bolt is going 20 miles per hour and Mr. Brock is going 25 miles per hour. Let's put that in. The slower person is doing 20. The faster person is doing 25. Now let's look at the time. Okay. Usain Bolt begins running at 3 o'clock. Mr. Brock begins running at 3:50. You would be tempted to put 50 in there, but remember, this is in miles per hour, okay? Where is that? Miles per hour. So we need it in hours. What percentage or what fraction of an hour is 50 minutes? Well, that would be 50 out of 60, which would reduce to 5/6 of an hour. Okay, since we want to know how long it's going to take Mr. Brock to catch up, I'm going to let Mr. Brock be T for time. Since Usain Bolt had a 5/6 of an hour head start, I'm going to say that his time is time plus 5/6. And I'm going to put that in parentheses so that I remember to distribute. Okay, now all I need to do is multiply these out. 20 times t is 20t. 5/6 times 20 is 100/6, which will reduce to 50/3. Let me erase this out of the way. Okay, next, 25 times t is 25t. Now, as I said earlier, the trick to this problem is at the point where the second person catches the first person, these two distances are equal. Here we have the rates, here we have the times. Rate times time equals the distance, and the distances are equal. So I'm going to set up an equation to solve, which is 25t is equal to 20t plus 50/3. This is the equation that we need to solve to get the answer. Okay, I'm going to move. Ooh, what happened to the rest of my equation? 50t plus 50/3. All right. So I want this equation. Okay, here's the equation I need to solve. First thing I'm going to do is get rid of that fraction of thirds by multiplying everything by 3, because I don't want to deal with the fractions. 3 times 25t is 75t. 3 times 20t is 60t. 3 times 50 thirds is 50. Now I have a very easy equation to solve. I need to subtract 60t from both sides. That is a 0 pair. 75t minus 60t gives me 15t is equal to 50. I divide by 15, and I get that t is equal to 3 and 5 left over, so that's 3 and 5/15, or 3 and 1/3 hours. Well, if I want to change that to minutes, I can simply say 1/3 times 60 over 1 gives me 20 minutes. All right, so that would be 3 hours, 20 minutes. And that's the same direction problem. Keep in mind that there's another way they could have asked this question. They could have given us the time that it took to catch up, in which case they would normally word it that Usain Bolt begins running later at 2 hours, or whatever the answer was, 3 hours and 20 minutes later, Mr. Brock begins running at 5 miles an hour faster. Then you would have to find the rate for each one of them. Okay, I hope this helps you solve the same direction problem.